Hello folks, in this video I'm going to show you guys how to use the TI-84 calculator or the TI-83 to do binomial distribution problems. Now before I continue on, please don't forget to like my video, comment below, share it, and subscribe. And don't forget to read the description below for more information about the video, the timestamps, and how to support me. Now in this example, I'm going to be using this textbook and problem, let me see, 50 and section 3.4. The problem states as follows. A particular telephone number is used to receive both calls, both voice calls and fax messages. Suppose that 25% of the incoming calls involves fax messages and consider a sample of 25 incoming calls. All right, so the first step is to write down what they're giving us. And the second sentence that they're talking about, suppose that 25% of the incoming calls involve fax messages are 25%. So that's our P. Consider the number of sample, lowercase n. Oh yeah, also lowercase p, lowercase n for sample number 25. And of course, our problem here is to talk about the number 6, which that will be our value, which is x. Now, something you guys need to, little background information here is that, and let me zoom in here a little bit. Binomial distribution or binomial probability distribution has 4 requirements. 1, the experiment consists of a sequence of n small experiments called trials, in our case 25. Each trial can result in one of the same 2 possibility outcome, either success or failure. In our case, they're talking about the calls we get from for the fax machine. Either we get fax machine calls or we don't. Trials are independent. That means then one does not influence the other outcome. The probability of success is constant. That means that 25% probability stays 25%. Okay. All right. Let me zoom out a little bit here. All right. So, letter A. At most, 6 of the calls involves a fax machine. So they want to know the probability at most. So, at most, you'll write down as so. Uppercase P, saying the probability when x is less than or equal to 6. That's what at most means. And mathematical symbols here. Now, in some textbook, you might see it as reading as so, like this. That's the 6 as most. When y equals 0, where it starts at 0, with your variable y, your number of trials or number of samples, and then you got your probability of success. Now, this is the more typical way to see it. This capital letter B, representing binomial, 6, semicolon, 25, comma, 0.25, close parentheses. Okay? Now, it's always helpful to draw a graph so you see what's going on. In our case here, for letter A, for example, here's the 6, here's the 25, and at most looks like this. So in our case, the calculators, and also if you see a table, most of the table, of course, read it from left to right. So let me turn on the calculator here. I'm going to go to second, vars, which represents what it says up here, distribution in blue. So blue bottom, blue command here. And here we have the different types of distributions. Normal distribution, T distribution. We're going down here some more. And we have the other distribution, and we have binomial. In this case, because we want from left to right, we'll be using the letter B, binomial CDF. Okay, so press enter. Number of trials is 25. Enter. Probability of something happening is 0.25. X value is 6. Enter, enter, enter again. So that will give us 0.5611. So that's the probability of at most 6 of the calls will involve fax messages. Now let's go to letter B. It's asking exactly 6 of the calls involve a fax message. Now exactly, if you recall from previous classes, previous chapters, the binomial distribution looks like a normal distribution. The difference more into looks more like a histogram looking kind of thing. Before we did the less than, that means from this point to that point to there to 6. However, this time we're going to be doing exactly a 6, which is right here. That probability. That's what they mean by exactly 6. And of course, we just do P parentheses X equals 6. Now, for this one, remember that before we were doing a binomial CDF, and this one, we're going to do binomial PDF in the calculator. So we're going to go to second, vars, right here. Go down to binomial PDF, letter A. Number of trials, we have 25. Probability, 0.25. X value, 6. Enter, enter, enter. So in our case, this will equal 0.1828. Note that I always keep it within 4 decimal places, just to keep it as accurate as possible. Now we're going to go ahead and do letter C. They're asking the probability that at least 6 of the calls involves a fax machine. All right. So at least that means that 6 or higher. Okay. Now to do the 6 or higher, we'll need to do a little bit of adjustments here. We will have to rewrite this. There's the symbol, as you guys can see. X is greater or equal to 6. That means they're involving 6 or higher, including 6. So to make that happen, we'll use, again, we're going to be using CDF. However, we're going to do the following. 1 minus P x less than equal to 5. What that really means is that we're going to be doing, starting from the 5, because we want to include the 6, and then we're going to go ahead and do the 1 minus, for the reason that the calculator only reads it from left to right. So the calculator is going to end up giving us the number. Okay. So this part right here is going to give us up to here. Well, but we want the other side. And remember, the whole thing equals 100% probability. We will just want that little part, and then we're going to do a 1 minus to give us the other side. Okay? Let me show you in the calculator, so you will see. Again, we're going to go to, let me clear this first. Second, vars, all the way down to the letter B, binomial CDF. And we're going to do number of trials. It's going to be 5 this time. And the probability of something happening, 0.25. X value 5. I think I did a little typo. Let me go back there again. See? Oh yes, number size 25. Sorry. This again. Enter. All right. Now that is going to give us all right. Let me erase this part right here. Okay. Just so we can have some space. That's going to give us 1 minus 0.3783. Okay. That's this part right here, which is 0.3783 right here. Okay. But we want the other side. Remember, we want 6 and greater, because it's at least 6. So 6, including 6 and above. So then we're going to do the 1 minus. We're going to go up here, push this up, press enter, enter. So the final result gives us 0.6217. So that's how you would do what the probability that at least 6 of the calls involves a fax machine. Do the 5 and then do 1 minus. Okay? All these problems in this textbook is similar. The thing they change is the numbers, the values, and just the way they reword the problem. Now, problem letter B. What is the probability that more than 6 of the calls involves a fax message? More than 6. So they want 6 more than 6. So anything above the 6. So it will look like this. So that's the 6. So it's just like, maybe like 6.0000, 0001 and above. So in that case, notice there's no equal sign compared to the one before it. See? So this one, we're going to be doing almost the same thing, but in this case, we're going to be using the 6, the actual 6, and doing 1 minus. Because this information here, this part right here, is going to give us this shading area here. And doing the 1 minus will give us the other side. Okay, so let's go ahead and do this in the calculator. Let's clear this second bars. Oops. Wait, got turned off. Wait, sorry. Clear second bars all the way down with this binomial distribution CDF. Remember CDF here. We're doing this one. It's gonna be CDF. Okay. Press enter. Trials is 25. Probability is 0.25. The value x is 6. Paste. Enter. Okay. And of course, it's going to give us the same answer as the first problem because it's similar. However, we want to do 1 minus. And I'm going to go up here and click here up. Enter. Enter. And it's giving us equals 0.4389. All right, that's it, guys. So thanks for watching. Please don't forget to check the description below for more information where you can follow me and how to support me. And have a good day.